Bismillah, Salam, Rasulullah. Let's do this. Analyzing categorical data. By this unit, you're grouping things by anything other than numerical values. You're grouping them by categories. By learning how to use tools such as bar graphs, Venn diagrams, and two-way tables, you'll expand your abilities to see patterns and relationships in categorical data. Okay, where are we? Nope. I'm happy where I am. Sixteen units, 57 skills. I got 5. We are still at level 4. It said level 5 a while ago. 2 out of 4 skills. What's happening? I don't get this. I honestly don't get it.
Let's say that we are trying to understand a relationship.
Wait. God damn it. 83%. Quiz 3. Unit test. Okay. So we're here.
In a classroom of 200 students, between the amount of time studied and the percent correct. And so what we could do is we could set up some buckets of time studied and some buckets of percent correct, and then we could survey the students and or look at the data from the scores on the test. And then we can place students in these buckets. So what you see right over here, this is a two-way table, and you can also view this as a joint distribution along these two dimensions. So one way to read this is that 20 out of the 200 total students got between 60 and 79% on the test and studied between 21 and 40 minutes. So there's all sorts of interesting things that we could try to glean from this. But what we're going to focus on this video is 2 more types of distributions other than the joint distribution that we see in this data. One type is a marginal distribution. And a marginal distribution is just focusing on one of these dimensions. And one way to think about it is you can determine it by looking at the margin. So for example, if you wanted to figure out the marginal distribution of the percent correct, what you could do is look at the total of these rows. So these counts right over here give you the marginal distribution of the percent correct. 40 out of the 200 got between 80 and 100. 60 out of the 200 got between 60 and 79, so on and so forth. Now, a marginal distribution could be represented as counts or as percentages. So if you represent it as percentages, you would divide each of these counts by the total, which is 200. So 40 over 200, that would be 20%. 60 out of 200, that'd be 30%. 70 out of 200, that would be 35%. 20 out of 200 is 10%, and 10 out of 200 is 5%. So this right over here, in terms of percentages, gives you the marginal distribution of the percent correct based on these buckets. So you could say 10% got between a 20 and a 39. Now you could also think about marginal distributions the other way. You could think about the marginal distribution for the time studied in the class. And so then you would look at these counts right over here. You'd say a total of 14 students studied between 0 and 20 minutes. You're not thinking about the percent correct anymore. A total of 30 studied between 21 and 40 minutes. And likewise, you could write these as percentages. This would be 7%, this would be 15%, this would be 43%, and this would be 35% right over there. Now, another idea that you might sometimes see when people are trying to interpret a joint distribution like this or get more information or more realizations from it is to think about something known as a conditional distribution. Conditional distribution. And this is the distribution of one variable given something true about the other variable. So, for example, an example of a conditional distribution would be the distribution of percent correct given that students study between, let's say, 41 and 60 minutes. Between 41 and 60 minutes. Well, to think about that, you would first look at your condition. Okay, let's look at the students who've studied between 41 and 60 minutes. And so that would be this column right over here. And then that column, the information in it, can give you your conditional distribution. Now, an important thing to realize is a marginal distribution can be represented as counts for the various buckets or percentages, while the standard practice for conditional distribution is to think in terms of percentages. So the conditional distribution of the percent correct, given that students study between 41 and 60 minutes, it would look something like this. Let me get a little bit more space. So if we set up the various categories, 80 to 100, 60 to 79, 40 to 59, continue it over here, 20 to 39, and 0 to 19. What we'd want to do is calculate the percentage that fall into each of these buckets, given that we're studying between 41 and 60 minutes. So this first one, 80 to 100, it would be 16 out of the 86 students. So we would write 16 out of 86, which is equal to 16 divided by 86 is equal to, I'll just round to one decimal place, it's roughly 18.6%. 18.6, approximately equal to 18.6%. And then to get the full conditional distribution, we would keep doing that. We would figure out the percentage 60 to 79, that would be 30 out of 86. 30 out of 86, whatever percentage that is, and so on and so forth in order to get that entire distribution.
Okay, next exercise. Let's do this. A veterinarian collected data about the kinds and sources of pets from his clients. Here is some of the data. Pet source, okay. Dogs, cats, total. What is the best description of the distribution boxed in the last column? The table above. What do you mean? I would think it's marginal. James is interested in the relationship between weather conditions and train delays for a year. James records the conditions each day as well as whether this train arrives on time or is delayed. Here are his results. The graph of which distribution is shown below. time status. Choose one answer. Delayed. Cloudy 5, 15. Rainy. Snowy. Snowy is 12. It's less. Here it's more. 60%. On time. On time. Delayed. Should be less than the 15. The delay. Rainy is 15. Okay. On time and delayed. So the condition, a further condition for each on time status. For on time لا ولا هو for each weather ولا هو of arrival of arrival إلا of arrival status. It's an arrival صح؟ Train for years record container arrives on time or delay. Okay. Each day of Spirit Week at Alex, school students have the option of dressing up according to a different theme. On Tuesday of Spirit Week, Alex record of students at his school by class and style of dress. Here is his data. What's the best description of the distribution boxed in the last column of the table above? Margin. Okay, game started. As shown below. Chess checker, Mancala. Not the game win. The marginal distribution of game played. Say this one. Okay, awesome. You improved your skills. Should we take another exercise? Ready to practice? Okay, show us what you can do. Let's do this. Military status. Find the marginal distribution of military status in percentage. Now in armed forces, 87. 87 over 55, 519. Very lazy. Oh my god. Here's 12%. What do you mean? It's not even one. Are you for real? I don't know how to write this. Got a problem with the rounding problem. Let's say 16. Okay. Military dependent. 1709 over 55, 519. In 100, 3%. 3. I don't know what does it mean, whole percent. Okay, civilian. 908. Can change that later. Civilian. 53, 723 over 55, 519. It's 96.8. That's not gonna work. 96.8. So what are we gonna say? 97.31. I know. I don't think this will work. Come on. So what is this? 96. Okay. Zero. Okay. So this is actually 0. 97. Okay. James is interested in the relationship. Doesn't matter whether condition, sunny, on time, delayed, total. Find the marginal distribution of weather conditions in counts. So in counts 170 over 365. In counts. What do you mean? One seventy, 120, 55, 20. 170, 120, 55, 20. Okay. Commute duration one way, private vehicle, public transportation, other, total. What does that mean? One way, 15 minutes. Wait, yeah. Commuters in Alabama, what is it? Way length of commute. Okay, find the relative frequency marginal distribution of transportation method. Transportation method? What do you mean? Transportation. Transportation. Do you mean this? More private vehicle. One 887 over 1938. 97%. 9. I would say this is 0. And public transportation. 9 over 1938. 0. Okay, 42 over 1938. Doesn't add up, am I correct? This is actually 2%, right? And 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. 2%. I'd say this is 1. It doesn't even come to 1, but we'll say let's check. 0, 3. What do you mean? Eighteen, 87, 19, 38, 100.4. What does that mean? Is it 98? So this is 98, and this is 2. Are you saying what's going on? Round to the nearest whole percent. Show step 9702. Where's the third? The 3. Where's the third one? This will be 99. 97. Seriously? Okay. Here is a table giving the number of insurance status, insured and uninsured. Owns home 71.5. Insurance home. Find the marginal distribution of tenure and counts. Tenure by tenure and insurance status. What does that mean? Owns home, rents home. Owns home 70. Okay. In counts. So 76. 30, 40. I am not gonna do it again. Let's practice. Okay, show us what you can do. Leon is interested in the relationship among geographic region, Democrats, Republicans, Independents, data. Give the conditional distribution of region of senators in the Republican Party. Republican Party of for senators in the is the Republican. So it's about senators at the time and the region. They use that the Republicans 55. Of region. Okay. So 20 over 55. 20 over 55. 36. Nearest tenth of a percent. Oh my God. 36.4. Southwest 5 out of 55. 9.1. And then we got West 10 over 55. That's okay. This variation is 118.2. And then we got Midwest 11 over 55. 5. That's 20. So here we got 20. Okay. Okay. Which graph displays the conditional distribution of region for each political party? Region. Democrats, Republican, Independents. I don't see the third color. Can you see it? Is there a color? Yep. Is the difference here? Independents only here, northeast. Only one, northeast. So I guess it's this one. Political party. Choose one answer. Of region for each political party. To me, it's the same. I don't know how is it different. Probably the different in this center, in this statement, whatever, in this stamp. Political party here it says region. Let's check. Okay. Can you explain? No, wait. Can you explain why did you choose this? Okay. The following table. Okay. First class. Which of the following interpretations are correct? The person survived. It's more likely that the person was in the crew than any other individual class. Crew survived. Correct. Not a big difference, but given that a person was in the crew, it was more likely that the person died in that cell than survived. Crew, correct. If a person died, it's likely that the person was in the third class or crew. So this, it's more likely. I don't like more likely here because it's only 215, 202. So I guess I'll gamble here. Okay. Got a problem with the statistics, linguistics, or language. Ah, languages, allergies, no allergies, total. Give the conditional distribution of whether or not the person has allergies for the students who speak two languages. Two languages. The conditional distribution of whether or not the person has allergies. Two languages. Allergies. 19 out of 33. $57.6. So 114 over 33. 42.4. Well, article distribution and relationships, college grades. Okay. Distribution of the data is highlighted below. Quiz. Is this a quiz or article or marginal? Okay. What conclusion can we draw from the highlighted display? There are far more students. There are undergraduates. Okay, undergraduates, graduates. Yep. Officials. Okay. Calculate the conditional distribution of straight A status for each level of student. Straight A. No calculator. 240 out of 300. Okay. Point 80. That is 20. That is not 160 or 40. What do you mean for 40? For 89 points. Is there 89.5? 89.5. I don't think this is for each level. Distribution of straight A status. Doesn't say not, but of course this is the rest, which is 10.5. 9.5. Okay. Seriously? $11? What seems to be the problem? This is not gonna work because you see this is, but this doesn't add up. So you're gonna have to do it on the total. So we got 240 over 4,500. That's a 5%, 0.3. And then we got 60. What are we getting at? $60 over 4,500. 1.3. And then we got 3,760. 500. 83.5. And then I think this is 20. 9.7. No. Does it add up together? $99.8. Calculate the conditions of straight A status. Straight A for each level of students, which means this and this, only this and this. 240 out of 4,000. We did them all. 240 out of 240 out of 4,000. 6. This is 94. And here we got 60 out of 500. 60. That's 12. Which means this is 38. Check. Yeah. Based on these conditional distributions, what can you say about the association between student and a straight A student? Nope. Yeah, this is not right. This is more likely. Straight A students were more likely to be graduate students than undergraduate. Straight A, graduate, 12, 6. It's correct. Students were more likely to have straight A. This is not true. Students were more likely to have straight A than graduate students. Wrong. What do you mean? Yeah, I took the percent, but look at the number. Undergraduates were more likely to have a straight A. This is misleading in so many ways. Oh yeah? More likely to have straight A students. Undergraduate. 240 and 60 graduate. So, seriously? What does that mean? Back here at the percent, I needed to explain. Okay, explain. These conditional distributions. 6% of undergraduate students had straight A's compared straight A's compared to 12% of the students. Those students note the third choice is wrong because there are 300 total students with straight A's. The majority of them, 240, were undergraduate students. This doesn't mean that students are more likely to have straight A's, though there were a lot more other students than graduate students in general. So a lot of the straight A students are undergraduate. However, a low percentage of undergraduate students have straight A. Distribution shows this one variable in percentages for a specific value of the other variable. What does that mean? Straight A for each level. My God. Can you believe this? For this college, is there an association between the level of student and whether or not the student has straight A? Yes. Okay. Quiz 3 is what we're gonna finish today. Here is a table classifying ones. Okay. Assurance. Find the marginal distribution of tension and percentage. On zone. So I got 76, 71 out of 76. %, marked for. No, 93. Okay, the rest is here, 7. No? 5 over 76. 6.5, which means 7. Point 5 and this is 7, meaning it's gonna be 6, 7. This is 7. This is 93. What are you talking about? Why are you making this so hard? Round to the nearest whole percent. Does this mean that this is 6? Four. I don't know. 5. Owns a home, rents a home. Owns a home, this one. Owns a home. So, out of all of it. So I got 76 out of how? 76 plus 40. That's 116, and we'll say x over 116, 65, 66, 66, 34. Lara surveyed, okay. Complete the table giving the conditional distribution of number of languages spoken for students with no allergies. So we got no allergies. (25 over 47). 53, nearest tenth, 53, 53.2, 19 over 47, 19 over 7. Oh my god, 40.4, 40.4. Then we got 2.47. That's 4. 2. 2. We got 1 over 47. That's 2.1. Am I correct? Hopefully. What's going on? Tenth of a percent. The nearest tenth of a percent. Complete the table given the conditional distribution of number of languages spoken for students with no allergies. No allergies. Oh my god. No allergies. 28. 28 over 44. 63.6. 63.6. Okay. 14 over 44. 31.8. And then I got 1. Let's say 1%, 1%. 1 over 44. Actually 2%. 2.2. What's going on? 1.4. What's happening? No allergies, no allergies. So what's happening? $31.8. So what's happening? 1 over 44. 2.3. 2.3. 3.3. God damn it. What? Best description. Marginal distribution of gain is the marginal distribution of style of outcome. Is the conditional distribution of gain for wins. Is the conditional distribution of outcome for checkers. Which graph displays the conditional distribution of number of languages? Of number of languages spoken for students with allergies. Allergies. Number. For allergies. Okay. Find the marginal distribution of military status in counts. Military status. Oh, the distribution. Status in counts. So we'd say in armed forces 28 plus 59 87 928 plus 781 1709 26 393 plus 27 30 53 723. Unit test. So this is it for today, you guys. See, this mundane work, it's gonna end when we get into machine learning and data science stuff, because Python is gonna do all of this to us. Panda and scikit-learn and PyTorch are gonna do all of this for us. Okay, but you need to understand so that the outcome of that code you could understand, interpret, or how to use it, when to use this and when to use this. Anyways, this is very much needed for data science and machine learning. All right.